All right, guys, we're going to go ahead and get started here on 4-5. First thing up is the warm-ups. Go ahead and pause the video, work through 1 through 3, and then play it back. All right, so here we go. Number 1, name the angle formed by ray AB and ray AC. So if you don't see this answer, what you're going to need to do is draw it. So we have the common endpoint here, A, for both rays. So you start with A. And we're going to draw AB. We don't know where the angle is, but it's a ray. But I can make the angle any size you want. And we have AB and then AC. So the angle formed is going to be angle BAC. This concept will be used as we go through our lesson dealing with included angles. Okay. Next up, number 2, name the 3 sides of triangle ABC. Again, all you're doing is, you draw a triangle. Triangle A, B, C. So you got, AB. It's a side. You have BC, and you have AC. Let's make sure you include all the sides. Okay. Number 3, and that's all you have here. Number 3, we have 2 congruent triangles, so we name all pairs of congruent and congruent corresponding parts. This is a review from the last lesson. So if I list my sides, I'll do that first. So my sides, we have QR and LM, the first 2 points in each. So if QR, that's congruent to LM. You don't have to say congruent, you can just say QR and LM because they're saying name all pairs of congruent corresponding parts. So just by listing them, you're saying they're congruent. But I'm going to write the statement out. So I have QR, and then I'll do RS. So segment RS is going to be congruent to segment MN, second and third points from each one. And then we'll do QS. So QS, not QR. QS is congruent to, again, first and third. First and third is LN. So those are your sides, and then your angles go pretty quick. Your angles are, again, just angle Q, which is congruent to angle L, angle R, which is congruent to angle M, and angle S, which is congruent to angle N. So those are your congruent sides, your congruent angles, those are your congruent parts. Okay, so there's your warm-up. So let's kind of talk about how we're going to use all this information in 4.5. So today we're going to be learning about 2 congruence theorems. Again, 4.5 and 4.6 kind of go together. You'll see that as we go through each lesson. For 4.5, we're going to learn about side, 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 and side, angle, side. And in 4.6, we'll learn about angle, side, angle, and angle, angle, side. Again, the concepts are going to be very similar, but in the previous lesson, we learned how to prove triangles congruent. And we learned it by showing all corresponding parts were congruent. Well, with these theorems, we don't have to show that everything is congruent. We just need to show that just a certain amount of information is. And that's what these theorems are going to be discussing. So we're going to be able to apply in this lesson side, 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 which is SSS, and side, angle, side, which is SAS, to construct triangles and solve problems. We're going to be able to prove triangles congruent using these theorems. This is going to be a big theme as we go through this lesson, is the whole concept of proving. Okay? So we're going to be doing lots of proving. Get ready. Hopefully you're already ready. Okay. I lost my colors. Where'd they go? I don't know where my colors went. I'm sad. Oh well. Okay. Moving on. Lesson 4.3, again, this is what I was talking about. We proved triangles congruent by showing that all 6 pairs of corresponding parts were congruent. We're not going to do that now. The property of triangle rigidity gives you a shortcut for proving. That's what these theorems that we're going to be going over will show you. For proving 2 triangles congruent. Again, it states that if the side lengths of a triangle are given, the triangle can only have one specific shape. Okay, so again, the lengths are given, we can only have one shape. So, for example, if I had a triangle with the three different side links. So I have this side, and I'll use side, side, side to get started. So I have these three sides, and I try to construct a triangle. Again, you would start, let's say, construct the bottom. I got this side. And then you would say, well, let me go ahead and put this side up. Now, you can put it where it goes in the same angle here. If you didn't, and say you moved it out here, this side wouldn't reach. You'd have this extra space. And you'd be like, okay, I can't make it fit. You have to bring it back over here for the points to touch. Whole concept here is there's only one triangle you can draw if you have these three sides. So there's only one triangle that, again, we'll be able to set up. And again, that'll bring up our side, side, side theorem. We have proofs, obviously. We'll go through these things. All right, so there's our side, side, side congruence theorem. So to prove triangles congruent, instead of showing that all three pairs of sides and angles are congruent, if all we know is that the three sides of one triangle are congruent to three sides of another, then we have congruent triangles. Now remember from 4.4 is that, you know, these triangles can be in all sorts of different orientations, but the congruent statement, all the corresponding parts need to be listed in the proper order. But again, we only need side, side, side now. This is going to be one of our next postulates. I kind of showed you, I think I said theorem, sorry. I kind of showed you just, again, how we can draw it. I don't have to do a full proof for this. I can just draw the three sides. I can literally give you three sticks and ask you to make a triangle. And if you have those three sticks, there's really only one type of triangle you can draw, because those sticks would kind of come together at only one point if you decide to make a triangle. So since you can just draw this, you know, to go through a formal proof, again, you can just call this a postulate. So again, just concepts to remember here: adjacent triangles share a side. So, so this is like, you'll see this in some of our proofs. We'll have two triangles here. All right, sorry. So if I had a triangle, I'd have three sides. And I was going to kind of talk about these adjacent sides. That's going to be a side that shows up in both triangles. So like if I drew a side right down the middle here, this would be adjacent, an adjacent side, because two triangles, say triangle ABC and triangle BCD, would share this side. This is going to be my adjacent side. So again, the thing to remember here, adjacent triangles share a side, so you can apply what's called that reflexive property. I remember I talked about that in chapter 2. We don't really use it that much until we get to this point, to get a pair of congruent parts. Okay, so that's something we'll need to keep track of when we do our proofs. Okay, so part of going through talking about adjacent sides, we'll use it to explain why two triangles are congruent. Now we can do this in just an explanation problem, or we can do it as a proof. All right, so let's go ahead and get started here. So anyway, we're going to use side, side, side to explain why these triangles are congruent. So right now we have two congruent pairs of sides. So we have side here and side here. So right now what we have is we have that AB, oops, let me get that, AB is congruent to, and if I look at AB, I'm looking then at also CD. So I know these are congruent. That's a side. So that's a side. I have AD. Well, AD is congruent to CB. That's a side. I need to show my final side, which basically says that AC is congruent to AC. And that would be my final side. Now the reason for this is going to be that reflexive property. So if I was going to list out this, explain why these are congruent, use side, 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 you would have AB is congruent to CD, AD is congruent to CB, and that's given. AC is congruent to AC by the reflexive property. Therefore, you can say that triangle, and I'll go ABC, is congruent to triangle CDA by And again here we just say side, side, side. There's your reasoning that goes along with it. Alright, so that's going to be, again, using reflexive properties to show triangles are congruent. Alright, so that's a quick example of side, side, side. Now I'm going to talk real quick about side, angle, side. We're going to kind of get that set up here in just a second. But before we kind of talk about side, angle, side, I want to talk about, again, the angle part of that. We didn't have to worry about angles with side, 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 but we do with side, angle, side. So with side, angle, side, we need to understand what an included angle is so that we know if we're dealing with this, this postulate or not. So an included angle, is an angle formed by two adjacent sides of a polygon. So here angle B is the included angle between AB, segment AB, and segment BC. Now again, A would be the included angle between AB and AC. You got to think the two rays that form the angle are going to be the two sides that we use when we're comparing side, angle, side. Okay, so B is again the included angle between the sides AB and BC. Okay, moving on. Also, it can also be shown that only two pairs of congruent corresponding sides are needed to prove the congruence of two triangles if the included angles are also congruent, which is the definition or explanation for our side, angle, side postulate. So our side, angle, side postulate, notice here we have two sides and an included angle. Again, one has one tick mark, one has two, so you can kind of see which one stands for what. Here we have a tick mark, we have two tick marks, we have an angle included in between. This is a side, angle, side relationship. Again, side, angle, side does not mean that you just have two random angles and a side congruent. The angle has to be in between or included in between the two sides. It's not angle, side, side, or side, side, angle. It's side, angle, side. Again, the order that they list it matters. So here, this would be side, angle, side, side, angle, side, so I can say the triangles are congruent. Alright, so again, I was kind of talking about this, so you can just read that. It's what I just said. The letters side, angle, side are written in that order because congruent angles must be between, in between, pairs of congruent corresponding sides. Alright, so again, order matters. Alright, so real quick, again, we're going to use side, angle, side to explain why these triangles are congruent. So in this case, let me kind of write this up. I got side, I'll do it this way this time, side, angle, side. Okay, my sides here, I have to use my angle in between, but I got my sides that are given. I have BA is congruent to BD. So that's my side that was given. My angles, it looks like I have, and again, you can't just say angle B is congruent to angle B because there's two angle B's. Actually, there's three if you think about A, B, D. So you have to say, in this case, angle A, B, C is congruent to angle DBC. And that's going to be all given. So if I was doing a proof, we'll have a proof at the end here so you'll kind of see. But I was doing a proof, those would be given. Now I do need to find one more set of sides, and this is the one, again, we're using that reflexive property, and that is BC is congruent to BC, and again, that's the reflexive property, and let's say of congruence. So with all these things, I have side, angle, side. You can now say triangle ABC is congruent to triangle DBC by side, angle, side. And it's a postulate if we want to kind of put that in there as well. Alright, again, this could be a proof or not. It just depends on how they're asking you to do it. It's just use side, angle, side to explain. But this could easily be stated to prove that these triangles are congruent. And these would basically be the steps: given, reflexive property, and your final statement. Alright, so again, just kind of wrapping this up before we go into our proofs. I do need to finish with some proofs. That's what this chapter is mostly going to be about. We have the side, angle, side postulate guarantees that if you are given the lengths of two sides and the measure of the included angles, you can construct one and only one triangle. Alright, and that's, again, the postulate says that these triangles must be congruent if we have this relationship, which means there's only one triangle we can have, and they have to be congruent. Alright, so now we're going to kind of get into some examples and wrap up here. I'm going to get to our proofs here right after that, and then we got our quiz, okay? So 2 examples in our quiz, and we're almost done. Alright, so here we got show that these triangles are congruent if t equals 4. So if I'm looking at this example, we're just trying to show if we had a side-side-side or side-angle-side relationship. Well, in this case, we are going to kind of look more at a side-angle-side relationship. Now again, notice these triangles share side DB. So if they share this side, then I need to show that these sides are congruent and these angles are congruent. Now if they're congruent, that means that we should be able to say that 3t plus 1 equals 4t minus 3. But because see how these are both t, whatever I get for t here, if I plug it in for my angle, I should get 32. If I don't, then this is not congruent. These triangles aren't congruent because I won't have a side-angle-side relationship. Well, let's start out here by plugging in my t equals 4, and let's see what I get. So this would be 3 times 4 plus 1 and 4 times 4 minus 3, and see if I get that. So 12 plus 1 is 13, and this is 16 minus 3, which is 13. So that works. Now let's check my angles. I should know that 2 times oops, did that wrong? No, didn't really do it wrong, but 2t squared equals 32. See if this works. So this would be 2 times 4 squared equals 32. Well, 4 squared is 16, and 16 times 2, well, it's not, oh, I wrote 36, that's my problem. Okay, so I say, oh, well, that's not going to work, but it will. I just wrote my number wrong, so that'd be 32, sorry. So 16, 4 squared, times 2 is 32. So these are actually equal. So again, show that they are equal. So I would say triangle ADB is congruent to triangle CDB by side angle side. But again, this is more about the work. You don't just write the statement and say, all right, I got it right. You have to show it. So the work has to be attached if they're saying show. Not just good to write the statement. That's not going to be good enough. It's the work that I'm looking for. Okay. Alright, so to wrap up again, I'll give you a second if you want to write this down. Get the statements and reasons written up so we can do our proof. Okay, so for this one, I'm going to go ahead and write up our proof for, we're trying to prove now that these triangles are congruent, so we can use again side angle side or side. In this situation, it looks like we're going to use side angle side. So looks right off the bat, we got QP, ray QP bisects angle QRS, which I have here. So I'm going to write given right off the bat. They say QR is congruent to QS. Well, it looks like that's cut off, so I'm going to put that in as step 1. So QR is congruent to QS, and that's given as well. Sorry, my phone's going crazy. I'll move that. Okay, so I have these are given. I'm going to go ahead then and use what I know to fill in the rest here. I'm just trying to find a good color right now. So I know because QP bisects RQS, I know these angles are congruent. Okay, because of the bisector definition. So I'm going to say definition of bisector for my next step. And then next up, I know that QP is congruent to QP. I know that because of the reflexive property of congruence. So now I have my side angle side relationship. Hopefully you can see the included angle in there. It's the angle in between the two sides. So these triangles then are congruent by the side angle side postulate. So again, hopefully you're writing down these reasons, keeping track of them as we go through this chapter. Reflexive properties getting used. We've used definition of bisector already. We're still using it. So hopefully you're kind of getting the hang of those. So these proofs won't be so bad because they're really going to start adding up here in these next few lessons. Alright, so with that we got our lesson quiz. There's 2 parts to the lesson quiz. Part 1, again, show that these triangles are congruent when x is 6, just like the example I did in the notes. Plug in for x, and then see if we're going to have side angle side or side. Okay, but you have to show the work. Don't just write the statement that the triangles are congruent by whatever postulate. I need the work. Number 2 and 3, again, which postulate can be used to prove the triangles are congruent? Again, sometimes you may have to, here you can probably add some angles and stuff, but again, add as much as you can, and then look and see, is it side or side angle side? Okay. If you don't get either one, then you say neither. Part 2, we got a proof. Pretty self-explanatory, right? Fill in your given statements and go from there. All right, so we got our proof for number 4. And with that, fill in your reflection, and I'll see you guys in class. All right, guys, we got the warm-up here for 4.6. Go ahead and give it a shot real quick. Hit pause and then hit play. Okay, so here we go. Number 1, what are sides A, C, and B, C called? And then they'll say, obviously, side A, B as well. So this is just a right triangle. So this is some definition things that you need to know. If you don't know already, well, here you go. These sides right here, if you're looking at a right triangle, let's start with AB, actually. This is going to be your hypotenuse. And that's going to be the side across from the right angle. Remember, the hypotenuse is always the largest side of a right triangle. Now these other sides, you need to be aware that they are called legs of the triangle. So again, these are two legs. You always have 2 legs, and then you have the hypotenuse. So when you're dealing with the right triangle, that's what you call those sides. So that's what that problem meant. Next up, it says which side is in between these 2 angles, A and C. So I'm looking at the same figure up here. I got A, and then I have C. So I'm looking at the side that's in between them, and that's going to be this side right here. So that would be side AC. It's in between those angles. Next up, given triangle DEF and triangle GHI. So let me kind of come up here. I'll go triangle DE. Let's label first. Okay, so I have triangle D, E, F, and it looks like we have some congruency going on. I mean, obviously this is a congruence chapter, so I'm going to try to draw them at least the best I can, make them look congruent. So DEF and then GHI go in the same order. Remember that the congruent statement is written. That's an H, by the way, and that's an I. Okay. If angle D is congruent to angle G, so D and G, and E is congruent to H, why is F congruent to I? So angle F is congruent to angle I. Well, hopefully you know this. It's one of our theorems that we're going to use in this chapter, which is why it's in the warm-up, or used in this lesson, I should say, by the third angles theorem. You can just see if you remember that theorem. That's all that is, and we're going to be using it. Okay, so there's your warm-up. All these things will be used in this lesson, so hopefully they all make sense. Okay, so our goals today, we're going to have 2 new theorems that deal with our non-right triangles, and one final theorem that's specific to right triangles. So we have angle side angle, which is ASA, AAS, which is angle angle side, and our right triangle congruence theorem, which is hypotenuse leg. Now, as we start to throw all these postulates and theorems at you, it's important that you understand which ones work and which ones don't. So when you're dealing with congruent triangles, again, to help you keep track of which theorems you can use and which you cannot, and theorems and postulates, the following angle side relationships work, and then I'll list the ones that don't work. So the ones that work, we did side, 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 and side, angle, side. We also have angle, side, angle, and angle, angle, side. Now, just so you know, when we list these, you know, side, 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 there's no, that's the only way you can say it. Side, angle, side has to be written in that order. Angle, side, angle has to be written in that order. Angle, angle, side, you could write as side, angle, angle, which is fine. Okay, it's the same thing. And then we have hypotenuse leg. So these are the ones that work. Now the ones that don't, one of them is angle, angle, angle. Give you a quick example. I'll give you a little equilateral triangle here, and I'll give you another equilateral triangle here. In equilateral triangles, the angles are always 60 degrees. 60, 60, 60, 60, 60, 60.
So just having the same angles doesn't mean that these triangles are congruent. So if you try to say, are these congruent? No, they are not. So angle, angle, angle does not work. The other one that doesn't work is side, side angle. On purpose, I wrote that as side, side angle, not angle, side, side, or else hopefully you kind of see what I might be spelling there. So usually, if I'm trying to show angle, 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 how it doesn't work, I kind of use that equilateral example. Now this one has a tougher reason, or tougher proof to show why it doesn't work. So I just use a statement to remember that this one doesn't work. It's a pane in the angle side, side. So that's a quick little statement, kind of help you remember that side, side angle is not a congruence theorem. So if you happen, if we're trying, it's going to be an easy little trap here. I'm asking you to show if two triangles are congruent, and you see that it has a angle side, side relationship, then no, they're not necessarily congruent. So again, in this situation, you could have two potential triangles that could work when you have a side-side angle relationship. So like if I tried, so just to kind of give you a heads up here, if I tried to set up a triangle, let's go, actually let me pause it, I'll draw them for you, okay? Alright, so here's your triangle. So I'm going to have an angle side, side relationship here. Now what I'm going to do is I'm going to take this side right here, I'm going to extend it out. I want you to see something real quick. And I can take this third side, and it's like I can rotate it so that it goes out here and touches it again, this bottom side. Again, what I want you to see is like this third side can actually form two separate triangles. One of those triangles is obtuse. See this obtuse angle? The other one would be an acute angle. So this would be, when you're doing a side-side angle relationship, it's one of two triangles that could be formed. Now there's one exception to this. The one exception to this is going to be if you have hypotenuse leg. If you look at hypotenuse leg, okay, this would be, I'd go hypotenuse and leg. Now in this situation, it's actually an angle side-side relationship. But if I tried rotating this side, I can rotate it over here, but it would be the same triangle. It'd have the same dimensions, just flipped. So, because you'd be able to kind of say it's, I can use angle, side angle to prove that these two triangles are congruent. So if it's a hypotenuse leg, in that specific situation, I can have an angle side-side relationship and it'd be okay, but it has to be a right angle. Because again, you don't have the issue of having an obtuse or an acute triangle if you have a right angle, right? So anyway, long story short, it's important that you know these. I didn't write these down for nothing. We should be writing these all down. Make sure you understand which congruence theorems work, since we're just about to finish going over all of them, and which ones don't work. You need to be able to keep track of them, because I don't want you accidentally saying, oh, I got an angle, angle, angle relationship, they must be congruent triangles. No, actually they're not. Same thing with side-side angle. Again, you don't know if they're congruent if all you know is a side-side angle relationship. Now if you have a picture, you might be able to. I'll go over that if the situation arises, but at this point we're not going to worry about it. Okay, so just know your congruence theorems and postulates, and then just make sure you know which ones don't work in case they pop up. Okay? Okay. So a couple tricks here about, again, make sure we understand how to use angle, side angle. We're kind of setting this up. This is the relationship you're going to be looking for. It's going to have an included side. So you're going to have two angles and a side in between those angles. Again, angle, angle, and then if I have a side here, that's angle, angle, side. It is not angle, side, angle. Okay, make sure, again, understand order matters. You can't just see two sides or two angles and a side and call it angle, side, angle. It doesn't work that way. Alright, so here's your angle side angle congruence. Again, if you have two, and this is a postulate, if you have two angles and a side that's included in between them, you will have an angle side angle relationship, and then you can say that triangles are congruent. Again, just make sure you understand that it is angle side angle and don't accidentally call it angle angle side. Again, just a couple examples. Again, this one will have different types of examples you could be tested on, so this is one of them other than just doing a proof. So this is just a situation here. We have if 7.6 kilometers, which I've given you, is a distance from B to C, is there enough information to determine the location of all the checkpoints? So again, if I'm looking at this, I have B to C. They're saying that is 7.6 kilometers. So if you're looking at this, this is ABC. I'm not going to get into bearings with you at this point, but if I had ABC, they're saying that A to B is 7.6, so that's 7.6. They're saying that B to C is 7.6, so it looks like I'm in an isosceles triangle. And then they're saying, do we have enough information to find AC? Well, again, what we have to deal with here is understanding, again, what are we given? From that, can I use any maybe congruous triangles, things like that, to find AC? Well, it depends on how you set up this triangle. Now, if I know, again, that this is isosceles, then I know that these angles are congruent. Okay, so from that, what you should be able to do is I should be able to set this up into two congruent triangles. So all I would have to do is set up a side right down the middle of that triangle. And again, since these sides are the same and these angles are the same, if I draw a side right down the middle, which creates a bisector, I can then set up an angle side angle relationship in both of my triangles. And if I did that, then I could solve this problem out. Now the question is, I know these are congruent. Are they asking me to find that side? No. Could I? Well, probably not. I need more information. But based on what I have here, it probably involves some trig, but I still could do it. Again, the question though is just saying, is there enough information to determine the location of all the checkpoints? Yes, there is. I mean, I'm able to show that I have congruent triangles. Now, the information I said you would need more information to solve this. I mean, I know that that's going to be a right angle. I could use the bearings to actually find these angles or do some trigs, but the whole concept of this question is there enough information to show that these are, to find these sides? There is, using congruent triangles. I know these two sides are congruent, so which means I could find AC. Okay? So, again, you can draw the sides if you need to set up your congruent triangles. So, yes. Again, you just show your work as you're doing it. Okay. Example 2, determine if you can use angle side angle to prove these congruent. Now this is, again, going to be a proof now. So I am going to prove this. So I'm going to go ahead and set up a quick proof. So in this case, I'm going to write down, again, you got your statements. You got your reasons. And I know that, just by looking at this, I know right off the bat, I know that KL is parallel to NM, which is given. Right from there, I can then say everything I need to say. I know that these are, I have some alternate interior angles here. I can say that KLN, so KLN is congruent to MNL by alternate interior angle theorem. Also, while I'm at it, I could see that's, in this case, that's angle. I have an angle. I don't have anything else. I could do, at the same time, I can do these alternate interior angles. Why not? Right? That's the same reason. So step 3, I'll say that angle KNL is congruent to angle MLN by alternate interior angle theorem. So now I got those. So the only thing I need it looks like here I got two sets of angles. I just need to include this side that's in between them to get an angle-side angle relationship. So I'm going to say, step 4, that NL is congruent to NL for both triangles. This is the reflexive property of congruence. So I now have an angle, side, angle, again angle, side, angle relationship here. So step 5, I will say that triangle NKL is congruent to triangle LMN. That's by angle, side, angle postulate, and we're good. Again, reflexive property is something we already dealt with before. Maybe you want to add the alternate tier angles into your reasons if you haven't put it in there already for another problem. And we're going to be doing lots of proofs. They pretty much follow the same pattern every time, so hopefully you can get the hang of these if you keep track of your reasons. If you're not doing that, you're going to be lost. I mean, it's going to happen, unless you're just really good at proofs. But if you're not, you better be writing these reasons down. Again, separate sheet for that. Alright, next up we'll do our angle side. This is a theorem, which means we can prove it. But again, angle side relationship. If we have that relationship in both triangles, we can say that the triangles are congruent. So again, angle side, remember in this case, order matters, the way you say it. So if you follow, let's get a different color marker here. So darker, you can see my pointer. Notice in this case, the side is not included. It's next to one of the angles. I could have had the sides out here. That'd be angle side. It's the same as, again, if I'm doing starting at G and I go angle side, but again, you're gonna have two angles, then a side, or two angles here, then a side. As long as you have that relationship, it's an angle side relationship, and you are good to go. So we have the proof. This is a theorem, so we're going to do a quick proof. You want to pause the video and then write this one down. This is the proof of the angle side congruence theorem. Alright, so in this one we have angle G is congruent to angle K, which they gave us. Angle J is congruent to angle M, which they gave us. So those are given to us. So I'm going to say given for my reason. And it looks here, they didn't, they have the HJ and LM later on. I'll put given in there while I'm at it. Okay, but step 2, we have to actually look at it. Say H is congruent to L. So again, I'm proving the theorem. So look, you can see when you look at the original picture, you have an angle side relationship, but I'm proving the angle side theorem. So you can't use that theorem as your reason, otherwise I'd be done already. We have to use a theorem we already have, like angle side angle. So notice if I can make this statement, I can do angle side angle. Well, this is that third angles theorem. As my n keeps disappearing on given, that's weird. Okay, it's going to pop up and go away. Just deal with it. Maybe it's just on mine and you can see n the whole time. I don't know. But my n has been disappearing on 3 for some weird reason. But anyway, go back here. It looks like I now have an angle side angle relationship. Again, that's a previously proven postulate or theorem. So I can use that to prove my next theorem. Right? We've already talked about it, so we can use it. So these triangles are congruent by the angle side angle postulate. So I got angle side angle, and we're good. Okay, so that's a quick little proof of angle side. Again, I could put that on a quiz if I wanted to. Wouldn't be so bad, right? So make sure you study it and know it. Now we can use it, right? So now we're going to use angle side to prove the triangle's congruent. Yay, another proof. Okay, so just like before, we're going to go statements and reasons. And step 1, let's write our given stuff. JL bisects angle KLM. I also have angle K is congruent to angle M. This is all given. Alright, there we go. Okay, so right off the bat we have that bisects. We've used this many times now, okay? JL bisects angle KLM. So that's telling me that these two angles are congruent right off the bat. So I'm going to say that angle KLM is congruent to angle MLJ. Again, you should know this by now. I mean, if we've been doing this, I don't know what you've been doing if you don't understand that if I say this is bisecting the angle, we can say the angles are congruent. I mean, I've been doing that since chapter 1. So this is going to be your definition of angle bisector. Step 3. I have angle. I look here. If I'd have angle side, just using the reflexive property, and I'll be ready to go. So I'm going to do that. JL is congruent to JL. That's your reflexive property of congruence. So that was quick. Angle side. Looks like I'm ready to go. So step 4, proof statement. Triangle JKL is congruent to triangle JML, and that's by angle side, and that is going to be your theorem. Again, a lot of the same reasons I've been using the last few lessons. Definition of angle bisector, reflexive property, again and again and again. So if you're keeping track of your reasons, you have those written down many times now, or you just put little check marks next to them, like, all right, I keep using this reason. Okay, they get used over and over again. All right, last one. Hypotenuse leg. Remember I explained this one earlier. This is an angle side-side relationship, but it does work if you have a right triangle, which is why we don't call it the angle side-side theorem. We call it hypotenuse leg because we want to confirm that this is only going to be true if we have a right triangle. So if you have a right triangle and 2 corresponding legs are congruent and the hypotenuse of each triangle is congruent, you can say that the triangles are congruent. Okay, only with right triangles, which is why again it's hypotenuse leg and not the angle side-side theorem. So example 4 here says determine if you can use the hypotenuse leg congruence theorem to prove these congruent. If not, tell what else you need to know. Well, here this is already given, by the way. CB is congruent to CB, so you don't say no here. You actually do have enough information. So it can be confusing. It says if not, tell what else you need to know. Well, again, that's given. Okay, so it may not say that they're congruent, but you can prove it congruent. So we're good to go here. So this would be yes. They would say, do you have enough information? Yes. All you need to do is say that CB is congruent to CB by the reflexive property of congruence. But again, if you have enough information, yes, I do. Okay. If they wanted to know what did you add, you'd say that CB is congruent to CB by the reflexive property. Okay. Oops. Alright, so we got a lesson quiz here using these theorems and postulates. So first part, again, identify the postulate or theorem that proves that triangles are congruent. We're just identifying angle side angle, angle side, or hypotenuse leg. Again, you might have to add information potentially to get that to work, but again, by the time you've added that information, you should have one of those theorems as an answer or postulates. And then we got another proof. So we got a proof here for number 4. Once you complete that, go ahead and fill out your reflection forms. And again, I'll see you guys in class.